Chapter 20 is based on volumetric analysis. I want you to have a look at this question and we'll try and work it out together. This is a question based on limiting an excess reagent. Okay, so they tell you so much of aluminium is produced. They want to know how much of aluminium oxide is required to react completely. So obviously, because aluminium oxide is reacting completely, that's going to be the limiting reagent. As you know from class discussions, it's your limiting reagent that determines how much of product is formed. And also remember that whenever we dealing with the balanced equations, we are most likely going to be using the mole ratios. In this case, the stuff we want, the aluminium oxide, will become the numerator of the ratio, and the stuff we've got becomes, which is aluminium, becomes a denominator, and you follow the working. The 2/4 is straight from the balanced equation. That's the coefficients of the Al2O3 and the aluminium respectively. Okay, you follow the working, and I think it's pretty straightforward from there. Right, let's look at question 2. You can see a balance equation written with the states as well. You need to calculate the mass of barium chloride required to produce 50 grams of barium sulfate. Your first step will be mole ratios. Right, although they're asking us for mass, remember everything can be related to moles. You work with moles and then you work back into mass and you get your answer out. Okay, follow the working. Okay, we see that the ratio is 1/1 and your number of moles of barium sulfate is equal to 50 grams over the molar mass of barium sulfate. So we'll just try and work that out. Okay, now we've calculated the molar mass, we stuck it into the denominator, and we are done with that part. Notice that I've put in units when working, so you can see in numerator I've got grams, the bottom I've got grams per mole, and obviously grams cancel off and I'm left with moles. Okay, now you can follow the rest of the calculation. Remember, we need to find the mass of barium chloride. We take into account, obviously, the equation that's going to help us is that number of moles is given mass over molar mass, and we work with that. Yes, and we get our answer of 44.62 grams, which is a mass of barium chloride that is required. Alright, please make sure that you can do this question. So I suggest you write it out, walk through it and try and understand it. If you've got any questions, you can come back to me. Now have a look at this question. This is on primary standard and standardization of hydrochloric acid. So have a look, understand, it should be a familiar question. We've done it in class during the pracs and during the SEC as well. Okay, let's have a look at the solution. Okay, we first try and determine the number of moles. Because that's given mass over molar mass, you get an answer of 0.0613 moles. And we're also given the volume. There's a relationship between number of moles over volume will give us a concentration, so that's what we want. Okay, as you see now in purple, we calculated the concentration of the sodium carbonate primary standard of 0.245 molar. Okay, now let's have a look at this question. We've done this in the practical SEC as well. You need to standardize hydrochloric acid using the known concentration of the sodium carbonate, which we calculated in the previous question. So let's just follow through on the solution. Okay, the question asks for a balanced equation. Here it is. You will notice that there's 2 sodiums on the left of the equation, so there must be 2 sodiums on the right of the equation. So that's why I put in the 2 in purple. Now, looking at chlorides, on your right I got 2 chlorides. On the left I've got 1 chloride. Okay, so I need to put make that 2 chlorides, and the only way I can do that, remember, I can't put the Cl at the bottom, I can't put the 2 at the bottom of the Cl, I have to put it in front of the HCl. Always when I'm balancing, I need to put in the coefficients, not subscripts. Okay, a lot of students are making that mistake. And also very important to show the state, which is aqueous in this case, apart from carbon dioxide, which is a gas, and H2O, water, which is liquid. Okay, now for question B, we just have to write down the information we got because that's on the other page. Now to make things easier, there's a 25 mol aliquot of sodium carbonate. You put that into the conical flask, okay, and you have to find the concentration of sodium carbonate. Also remember that concentration of sodium carbonate is written like this. Okay, so you can't write it as Na2CO3 with that bracket there. Okay. Okay, here again notice that number of moles is concentration times volume, and for concentration is moles per liter. I'm using units because it's going to be much easier to understand, and you can just see things cancelling out and you can understand why we're getting certain units. Now this gives us an answer of 6.13 times 10 to the minus 3 moles. Okay. Okay, now to answer part 3 of the question. Question 4C. Moles of hydrochloric acid for neutralizing sodium carbonate. I'm just writing the volume of hydrochloric acid required. The number of moles I don't know yet. What can we use? Yes, we have to use the balanced equation and go back to mole ratios and work it out from there. Okay, now from the calculation you see that the number of moles of HCl is 1.23 times 10 to the minus 2 moles. Okay, with going back to the ratio, you can see from the equation on the previous page that the number of moles of HCl to the number of moles of sodium carbonate is 2/1. The 2 represents the coefficient of hydrochloric acid from the balance equation, and the 1 represents the coefficient of sodium carbonate from the balance equation. Now question 4D is asking us to find the molar concentration of HCl. Okay, so I've written it in the 2 forms. I could write it with the bracket HCl or CHCl, which means concentration of HCl. Then you try and look for an equation where you have concentration in it, and that could be concentration is number of moles over volume. And because they ask for molar concentration, remember molar concentration is moles per liter, and remember I'm given volume in liters, in milliliters, 23.50 milliliters. Now to convert 23.50 milliliters to liters, I have to divide by 1000. That is why in the denominator I've got 0.0235 liters, right? And that gives me an answer of 0.523 molar, and we are done.